don't forget that tomorrow will be a short day because of the ACT. So the juniors will be coming in the morning to take the ACT. You will not come until the afternoon. So today's notes are going to be pretty short. We're going to do just one short topic because we won't have much time to work on the assignment in class tomorrow. So we're going to focus on isosceles triangles today. An isosceles triangle is a triangle that has two sides equal, one side different. So isosceles triangle has two sides the same. Well, when we learned the triangle inequality theorem, we learned that the largest angle is across from the largest side, or we could order the three angles according to the lengths of the three sides. Well, according to the triangle inequality theorem then, if these two sides match, the angles across from those sides should also match. And that's the main property of an isosceles triangle, is its two angles, we call these base angles, are the same. So some of these problems are going to be as easy as identifying, oh, what sides are the same, what angles are the same. Now the base angles don't have to be located on the bottom of the triangle. I can rotate my triangle. So if those two sides are the same, and I know this angle is 32 degrees, let's say I want to find the other angle. Well again, this is as easy as identifying, hey, this is isosceles. The two angles across from each other are the same, so question mark is 32 degrees. Or I could have called it x. We can make it slightly more difficult. Let's take that exact same triangle. But now let's say I want you to find this angle. This time I'm going to label it x instead of question mark. It's the exact same thing. Well, I don't know anything about 32 related to x right now. All I know is that the angles across from the sides that are the same are also the same. So I can label this angle also 32 degrees. But then we have to think about what we know on triangles. Triangles add up to be 180 degrees. So now I can set up an equation with all three angles. You know, 32 plus 32 plus x is 180 degrees. Now I have an equation I can solve. 32 plus 32 is 64. I subtract 64 from both sides. 180 minus 64 is 116 degrees. The last thing we can do with this is give information about the sides instead of the angles. And we can solve for entire equations instead of just finding the angle. So let's say I know this angle is 35 degrees, this angle is 35 degrees, 2x, and we have x plus 12. So I'm not going to state specifically that this is isosceles, but we can recognize, because these two angles here at the bottom are the same, that the sides across from each other are also the same. So mathematically, how do we represent something that's the same? Well, we use an equal sign. So if I set these two pieces equal to each other, I can then solve this equation. We do opposites. Our first opposite would be to subtract x from both sides. 2x minus 1x is 1x, but we don't have to write the 1 in front. And we actually don't have to do a second opposite on this equation. We're done right there. So again, Isosceles triangles, pretty straightforward, pretty simple. We're trying to do a short topic because tomorrow we're going to have a very, very short class time.